So it's Eamon with ipXchange. We're at the Embeetle booth at Embedded World, and they're going to tell us about their impressive IDE for microcontrollers.
We started Embeetle about 5 years ago because we were very frustrated with the quality of the available IDEs for embedded programming. I think all of us, we were experienced programmers. We know how to program C, C++, no problem for general purpose programming. We know electronics quite well, but still it would take us days, if not weeks, to get an LED to blink on an embedded board.
Oh dear.
Mostly figuring out what is the right version of Eclipse and its plugins that I need, or some other IDE, Visual Studio Code, whatever. Figuring out what should be the settings, how should it be configured. It was just terrible. So we decided we should do something about it. So the main point of Embeetle is that we take away every possible obstacle systematically that you encounter when you want to start a new embedded project.
Nice.
So the demo will try to demonstrate this, how in 10 minutes time, on a computer where you've never done any embedded programming, you can get the LED to blink on your target board.
Okay. Cool. So the target board there is a GigaDevice.
Is correct.
Nice.
Yes. But we have other brands as well supported. So the only thing that has been done on this computer, we have downloaded the zip file for Embeetle and unpacked it. So and then you double click Embeetle, you get this home window. Where, traditional things, you can open an existing project, a recent project, but for now we will just start a new project, which is this generate project. And it shows you a list of projects, sample projects that are available, with some filters here at the top, from which we will select now. Well, we have a GigaDevice board, so we can filter for Giga. We have currently 4 projects supported. If you look at the details here, it's the GDE 231C start. So you select it. The name for the project folder is automatically filled in, but if you don't like it, you can change it.
Cool.
You can decide where you want to store the project and just create. Downloading the project, done. Starting the project window. Here we go. Now, Embeetle noted that for this project, you need some tools. You need a make program, you need a compiler, you need a flash tool, OpenOCD. And specifically, since this is a GigaDevice board, you need a very specific version of OpenOCD.
Okay.
It knows this, it knows where to get it, and so it just proposes you to download these tools.
Okay.
You can change the selection if you want, but if you agree, you just press apply and it will download them.
And then it's all sorted for that specific
It's all installed, nothing else you need to do. No 20-page manual you need to go through to figure out where to download the correct version, and etc., etc. Now, here at Trade Fair, the internet connection is not terribly fast, so it will take some time, especially for the ARM toolchain to download.
So while that's happening, I guess we can explain a little bit more about Embeetle. So you have your software supports quite a lot of microcontrollers at the moment, but for every microcontroller, you kind of expand the software to support it.
Yes, well, we add some configuration essentially to make sure that when you download a sample project, it works out of the box. So our business model is that we provide the IDE for free to users.
Okay.
Anyone can download it, including using it for commercial purposes.
Okay, cool.
We talk to the vendors, MCU vendors, because we believe that adding support in Embeetle for their MCUs is a real, it will give a boost to their sales.
Oh,
because people really like it. It will make it so much easier to get started with their microcontrollers.
Yeah.
there are market studies that show that the selection of the next microcontroller for a new project is typically made not by management. They don't care so much. Often by the engineers, and it is often based not on the technical qualities of the microcontroller itself, but on the ecosystem around it.
Okay.
The ecosystem around it, where the IDE is a very important part.
So Embeetle's IDE gives you a lot more flexibility in what you can use because you don't have to relearn and reset up
that
everything.
As well, it's available, yes. Assume you're starting a new project and your boss asks you, we have these 3 or 4 potential microcontrollers that we want to use. Could you please evaluate them and give me a report by the end of the week?
Okay, yeah.
Okay, now if you need 3 days or 5 days to get the LED to blink on one of these boards, and the others are supported by Embeetle, and you can get them running in 15 minutes, and then start your evaluation, guess which will not be considered?
Yes.
Okay, the toolchain is almost downloaded. If you have a decent internet connection, this will be much faster, of course.
Yeah, we're all struggling.
The toolchain was the compiler toolchain was the biggest one. Now we still need make is already done, I think. Now the flash tool, but there we go. All the required tools are installed, and here's our project. I will explain in a minute what all these parts are, but just to demonstrate the point, we just press flash. You can see it's compiling the project now, it's beginning to flash, the LED stopped blinking, it's blinking again.
Nice.
Now just to prove that we didn't fake this, we'll scroll down a little bit in our source code. Here's the main file, here's the loop that makes the LEDs blink. We'll change the delay. Instead of 1 second with 1000 milliseconds, we make it 100 milliseconds. Press flash again. LED is blinking fast.
Cool. Very good. That was very fast.
Exactly. So, what do we have here? We have the simple buttons to clean your project, build everything, flash. Yep. If you didn't build it yet and you press flash, it will first build it. It's makefile based.
Okay.
In general, all of projects are based on the traditional open source tools, Make, GCC toolchain, or other compiler, OpenOCD, which means that you can also build your project outside of Embeetle, just on the command line.
Okay.
If you want it. There's no lock-in also. You can build this project with any other tools you like. We have the source editor. It has the source analysis tools, which means that it recognizes which symbols are there. Functions, for example, this function call is highlighted. You can click it. It will show this symbol. Where is it defined? Where is it used? Where is it declared? So all the cross-reference is there. We have it works both ways, by the way, so you can click here, it will bring you to the header where it's declared, etc. It will go back to use, okay? We have the diagnostics here, which will give you any errors in the source code before you compile.
Always useful.
Just to demonstrate, let's assign a variable here that we never declared. Oops, I'm not typing here. A equals 1, semicolon, I need to save, and we get an error. We use an undeclared variable here, and something else that I don't, what is this? Also, invalid digit, A in, okay, whatever. We clearly did something wrong. We have to declare the variable and then
Omdat er een stukje niet zichtbaar is.
Okay. Yes, right.
Er 2 keer instaan. Er is een heel stuk aan de linkerkant dat onzichtbaar is door die balk die daar staat
Yes. Yes, I'm sorry. We're screen recording and there's some stuff there. Let's just see it. Error is gone again. What else do we have here? We have the dashboard, which gives you a nice overview of all the current settings. The current board that we're using, the microcontroller, including the memory regions that are in use, how much of them is used. This is updated dynamically when you build.
Okay. It's very useful for you to be able to see.
Yes.
Good.
Most of the configuration, especially the more advanced stuff, is not in this GUI.
Okay.
We decided that either you are a naive user, you don't care about these configurations, you don't know much about them, you don't want to look at them.
Yeah.
Or you're an advanced user, but then you still, typically the advanced users hate the GUI configurations with thousands of options that you find in many IDEs. You prefer to do the configuration in a traditional configuration file, like a linker script, a make file.
Okay.
You have much more control. So that is what we do. For example, here in the project layout, we have the linker script. You can easily find it here. It's here. It is like treated like another source file in your project. Just treat it as source. You can click it. You can edit it. It shows here the memory regions that are defined for this chip. So let's just, for fun, add another memory region. I'll make it simple. Just we have RAM 2 as well as RAM 1, which is of course located at a different address. Just save this, and the dashboard will show the new memory region.
Nice. Cool.
Now, okay, I want to assign some variables in my code to this memory region. I can right-click it, and I can see, okay, there are no sections yet. Okay, it will probably take us a little bit too long, but you could just add here some sections.
Nice.
You can assign some sections from the compiled code to it. It will appear in the menu.
Cool.
Same way.
I think that's probably a very good overview of what it's capable of, what Embeetle's IDE is capable of.
Yes. Another nice thing in linker script here, you have a symbol here. This is the entry point of the program. It's reset handler. This should be defined as a function somewhere in the code. Okay. Okay. Here the cross references work as well, just like in the source code. So you can just click reset handler and see where it is defined. You have a definition in assembly code here, in this file. You can do exactly the same thing in assembly code. Symbols are highlighted. You can cross-reference. Okay. Is this thing used somewhere? Yes, it is. Just like in C or C++.
Cool.
What else? Okay, we have a selection of different probes that you can use. We're now using the online probe for GD-Link, which is for this GigaDevice board the obvious choice. But we have a whole range. All of them are documented on the website, how you want to use them, can use them or not. Some of them might be compatible with this, with the J-Link for Sega. We have the open, etc. They're all there. Blackmagic, very nice. What else? We have some support for libraries, which is currently mainly used for Arduino projects that we'll also support. And that's it. Cool. Almost. And then we have this part which shows the file tree, is the tree of your project. By the way, this is just the structure on disk. And the project is one folder. It is not like some other IDEs where files for the project can be distributed all over your disk, and you, through some mechanism in the IDE, you include them in the project, and then when you want to copy your project and send it to someone else,
it's a nightmare.
It's a nightmare to find all the required files. In a Embeetle project, you can just zip it, send it to your colleague, he can open it. If he has a Embeetle, it will tell him, oh, but you also need this tool, it will install it for you, and it will work.
Good.
Okay, another thing, you can store your project in any folder that includes folders that contain a space in the file, in the name. Try that with some Eclipse-based tools. Nothing works anymore. And it doesn't tell you what the problem is. Okay, These are just stupid little things, but just to illustrate that what we do is to remove all possible obstacles.
Nice.
Everything that is not important, not relevant when you just want to focus on your projects and get your implementation done, get your code written.
Cool. Cool. Thank you very much. That was a thorough explanation, and I can definitely see why someone would want to use Embeetle over using several different IDEs and struggling to make an LED blink for 3 days.
Okay. Okay, one special thing about this file explorer, well, of course you can just simply, there's the source code, the C code here, and click it, you can find the files. But the special thing here are these green and red icons.
Okay.
The squares are for C, C++ files for code.
Oh, okay.
The circles are for header files. There are none visible here, but if you look in the include directory, there are header files, they are circles.
Okay.
The ones that are red mean this C file is not required for this project. It's not used.
Okay.
So we don't link it. It's not taking any disk space, any space in your flash.
Okay.
The cool thing about it is determined automatically. You don't have to set it yourself. Embeetle checks the code and it figures out by itself what it thinks should be part of your project. Now, maybe it's right, maybe it's not, we can just try. It thinks that, let's say, sysdig should be part of your project, but let's include it. We disagree.
Okay.
Put the lock on it.
Show
What do
you
we
the
get? We
errors.
get undefined globals.
Yeah.
These 4 functions are not defined. So you actually do need it. If you build it now, it will fail. So we can force include it, of course that will work as well, but let's just put it on auto detect, it works well.
Nice.
We have the same icons on the folders, which shows here, it has a mix of green and red C files, similar for the circles for the header files. Now here, you cannot force include or exclude a header file because it's included from the C code.
Yeah.
If you want to exclude that, you have to remove all inclusions of this file from the C code. Now, where is it included? Open the file, it will just show here in the symbol window. It's included from 2 locations. So main.c, for example, it includes this file, there it is. What did I do? No problem. I can just comment this. This is not my keyboard, this is Slovenian keyboard.
What are you looking for?
The slash. No, this is the backslash.
That one?
Yes, sure. Let's comment this. Save it. Where is my header file now? Should I?
Just thinking about.
Am I taking too much time?
No. We're just double checking. We'll cut that audio out.
Anyway, it seems it's still included from the main.c. I did something wrong. I removed, commented the wrong one. I saved this. Of course, we get a lot of errors now. But here, this is the point I wanted to make. The icon becomes red, just because I don't include it anymore. Well, this is very useful, especially for drivers. It's typically in the sample projects that you get, there are a lot of drivers available. The GD libs here, firmware, for peripherals, for example. Source code is quite deep. A lot of driver code there. You don't need to worry, do I need this or don't I need it? Just include the header file, call the function, and it will be included in the project. Okay. That's it. And you don't accidentally continue to include drivers that you're no longer using. Here we're only using one of them, it seems. Just for this LED project, of course, that's all we need.
Cool.
Finally, what else do we have? A debugger.
Okay.
Additional debugger. Okay, we open the debugger window. Let's just put it next to the source code so we can see. And move this a bit. By the way, all these widgets, you can move them around, arrange them as you like. The debugger window shows a warning first. We haven't flashed the current program. Okay. So if we start the debugger now, the display might be inconsistent. It might show you, okay, well, first of all, probably we need to restore these includes. otherwise the project will not compile. Wasn't it in? Let's see. Call to undeclared function. So here. One. Giving no errors now anymore, so we should be able to flash. Flashing, okay, the warning disappeared, we're flashed, we can start the debugger now. Just connect. Here. It opened the source file here, it shouldn't be there. Probably because this is where it stopped. It stopped, of course, in Sysdig it has a delay function.
Okay.
We stopped the program that was running on the board now, so if you stop it at an arbitrary point in time, the chance is quite high that you stop in the delay function. Here we have the delay one millisecond here. We can see that this delay function, it's called from the main, the stack is there. The local variables, let's just move this a bit down. Local variable, that's just one count variable, is there. We can step through this, but most probably since it's a loop, it will take a lot of iterations, so let's just step out of it, go back to the main. Here we are. The next call we do is reset the bit. So right now the LED is on. We do a step, it's off.
Okay.
What else? As long as you're debugging, the source files are read-only. It will just warn you because debugging is active. Because if you would start to edit now, the debugger display would no longer be consistent again with your source code.
Yeah.
So you can't get confused.
Oh, nice.
Just disconnect if you want to change something,
Okay.
and you can continue. You can connect again. We have breakpoints, we have watch points. You can simply clicking there.
Oh, that's
I'm sorry, the screen recording software is again interfering, so it will be a bit tricky. Let's do it like this. We can put breakpoints, we can run, it will stop at a breakpoint, etc.
Okay.
Everything works less in a traditional professional debugger.
Oh, nice. Okay.
Any questions?
It's already way over my head, but it looks very, very thorough and definitely makes it easier to get started with.
To
with
get
things.
started with, and we want users to be able to grow, to become professional design, or we want it to be attractive for real professional, advanced developers as well.
Well, you already explained about the kind of shall we switch microcontroller. This makes that question much more easier to answer and quicker. So
Exactly.
yeah. Well, thank you very much, Johan. This is a very interesting, very different piece of content, unlike anything we've ever done before. So thank you for the opportunity.
You're very welcome. Thank you so much.
Yes.
For your interest.
Thank you.